Okay, so this is my task number 2 with the code space for the data science internship project. In this task, we're gonna see the sales prediction model. For that, we have to do the pre-processing of the data, train the regression model. We have to use the regression model and model evaluation and performance and make the prediction. So what we have to do, develop a regression model to predict future sales based on the historical data. So again, we're gonna import the important libraries, which is the Panda, NumPy, Seaborn, Matplotlib, standard scaling, train test, split, and the lasso for the model selection, select from model, and checking the performance of the model. We are having this absolute mean and mean square and R2 score. So we are reading the data. Here the PD underscore CSV. This is the CSV file. So we are using the read underscore CSV and viewing the top 10 rows. So the columns, you can see that we are having the price, area, bedroom, bathroom, story, main road, guest room, basement, hot water, heating, air conditioning, parking, pref area, and the furnishing status. So we're gonna first perform the analysis. So EDA part is going to come first. So we're gonna see the shape, which is the 545 rows and 13 column, including the price column. So checking the information, the data type of the column, which one is the integer and which one is the object. If this is the object, we have to fix this later before model building. And we have checked the null values. So there's no null values. Just give you the total null count. There is no null value present in this data set. So we are checking for the duplicates rows. So also there is no duplicate rows. So next we're going to check the value counts, which means the unique feature, unique character, which is going to inside the furnishing status, which is the semi-furnished, unfurnished, and furnished. This is the count. Plotting the disk plot and also the box plot for the area using the disk plot and sns dot box plot. This is for the area. This is disk plot area and box plot for the area. This is the title and label, and you can see that the distribution is right skewed. There's a presence of outliers. Next, we are checking the same for the price column, disk plot and the box plot on the price column, and see the distribution of the price. As you can see that it is also right skewed data. It is not normally distributed, and also there's a presence of outliers. Moving to the scatter plot. Scatter plot give you the relation between the area and the price column. So we have given the two column for the scatter plot, and we can see that there is a slight linear, like the linear relation between the area and the price. And also we're gonna see the relation with the categorical features and the price. For that, what I'm doing, all the columns which are the object data type, I'm going to store object data type, which I'm going to store in the category underscore feature, and group each feature, and I'm gonna take the and each feature plot against the price median. Why median? Because it is a skewed data. We have to take the median value for the price, and we are using the bar plot. Again, this is the x label. The x label is going to be this, the feature, and the y label. You can see that the price and the title is nothing but the feature. Whatever the feature going to be, that the feature name going to display over here. So for the feature main road, here you can see that if there is yes, means if there is a main road, then the price is high. If there is a guest room, then again the price is high. If there is a basement, then again the price is high. If there is a water heater, price is high. So moving to the air conditioning, so yes, if it is yes, the price is quite high. Moving to the pref area is for the yes, the price is high, and no, the price is low. For the furnishing status, if the house was fully furnished, the price was high, and semi furnished, the lesser than the fully furnished. Uh, if the price is very low, is because of the unfurnished. Okay, so moving next, the discrete data. So as we have seen, there was the continuous column and also the discrete. This is the discrete columns and this is the categorical ones. Perform the visualization on this discrete column. So what I'm going to do the same thing as the categorical, storing all the discrete features. This is not the object type inside the discrete underscore feature, except the area and the price. So again we are calling the feature from the discrete underscore feature and copying the data, and we are grouping these features and plotting against the mean. You can see that the if there is a number of bedroom, for number of bedroom there's a linear increase in the price, the linear relation between the price and bedroom, except for this bedroom number, this wing. And also for the bathroom it is a linear relation, linear positive linear relation between the bathroom and the price. And for the story also the positive linear relation. This is the parking, which is behaving same as the bedroom, which has increased. There was no parking, one parking, two parking, and for the third three parking, the price has decreased. So if you're taking the price and the area uh, column, first we are going to fix the skewness of the data by applying the log algorithm. See the same the dist plot for the both area and the price. So this is the figure size, the subplot, and the dist plot for the area and this plot for the price. Okay, so here you can see that the data somewhere in the normally distributed. Here some higher value, there's like two higher value, but yes, the distribution has become quite normal, and for the price the distribution has become normal too. So you can move fixing our categorical columns. We're gonna do the label encoding with the categorical columns. We're gonna take the oldest category underscore feature, which is having the object data type columns, and we are going, we are grouping the features in the price mean and sorting the next, like who is having the lowest price. For yes it's gonna assign a 1, and for the no it's gonna assign 0. Moving here you can see that all the yes no has gone, and it has got converted into the zeros, 0 1 2 into the discrete value. So we are viewing the top 21 rows, so there's no object column present. So what we have to next do is yeah, for the model selection. Before that we are seeing the correlation between the price and the features, independent features and feature to features. And we can see that with the price, whatever the column which is highly related to the price, we're gonna take those columns. Also this is for the visualization purpose, we're gonna use the lasso for the model selection. Price, you can see that if it is yellow or moving towards the greener side, it is highly correlated. Then this is the price column. The price is like quite good related with the furnishing status, preferred area, parking, air condition, but the relation between the hot water heating and the price falling somewhere in the orange shade, which is like not so correlated with each other. So and also there's going to be a basement, good relation, slightly good relation with the price. Guest is also having the good relation with the price. The main road, story, and the bathroom, you can see that it is slightly green, light green, so it is high, it's having the higher relation with the price. Also with the bedroom area, we are getting the good relation with the price. Okay, so finally you're gonna see the lasso. You divide the data into the independent feature and the independent feature. Y is the target one, which is the price column. So I'm going to give my this x and y to the lasso and fitting the x and y on the lasso to see which column is best for our model building feature, which is important as true and which is not important as false. These are the important features. So what I'm going to do is store the all important feature in the x column, which is going to be independent features, and by the r target. So we are moving towards the model building part. So we are doing the trend test split, where I have assigned 30% of the data as test data, and random underscore state. We have given a value 50. This is the top 5 rows of the test x train. This is the top 5 rows of the x test. This is the top 5 rows of x y train and the y test. Linear regression. For that we have to do the scaling. So calling the scale standard scaling and fitting transforming the train data and transforming the test data. So we are taking the linear regression and fitting on the x and y train and predicting. This is the predicting on the x test. This is all the predicted values on the x test data. And if you want to see that the original y test data, this is the value. So this is the 15 15 15 14 14. So like 15 16 14, like the slightly wrong prediction, but yes, close one. But let us close to the original one. The model performing, so we are having the mean absolute error as 0.16. This is for MSc 0.3, and the RMSc is 0.19. R2 score is 0.72, and adjacent R2 is 70. It is close by. Yeah, model is performing good, but we're gonna use one more random forest. So we are calling the random forest and fitting on the x and y train and predicting on the x test data. This is the predicted output. We can compare it with the test target y test value, the 15 15 15 14. This is the 15 15 15 14. We're like close one. This is also the giving good prediction, but we cannot check the performance of the model using AMA. This 0.16, 0.04 is MSc, RMSc is 0.21, has increased. R2 score has decreased, and adjacent R2 has also decreased. So what we're gonna do is perform the hyperparameter tuning using grid search CV, and in grid search CV we are giving the estimator the random forest. The parameter we have given the list of the values for each parameters. Choose the best number for the model, and then the scoring is negative mean square error, and we are fitting the model on the x and y train. Again we are doing the y prediction on the x test data. So this is the prediction, and this is the MAE, which is 6. It was previously 16 and it has dropped to 15. Good. It is I feel this is the same. This RMSc has dropped to 20, and R2, the R2 score has increased, but not so close with the R2 score. So we are finally choosing the linear regression model. Why it's having the absolute mean error as 16, whereas the mean square error we are getting 0.04, and here it is 0.03, and RMSc is 20, whereas for the linear regression it was 0.19, and for the R2 score it was 71 and it was 72 for the linear regression, and here it is adjacent is 0.69 and adjacent for the linear regression is 0.70. So our final model is going to be the linear regression. With this I would like to end this video. Thank you.